For question 15.10, we're given a mass of sodium hydroxide dissolved in 500 milliliters of water and then asked to calculate the hydronium ion concentration of that solution. So the first thing, all of these calculations depend on concentration, and we're given mass and we're given volume. So our first step should be to take the mass of sodium hydroxide and the volume that it's added to find concentration. So step number one, we need to find moles of sodium hydroxide. So I have 1.5 grams of sodium hydroxide. If I go to the periodic table and look up the mass of sodium, oxygen, and hydrogen, I see that for every 1 mole of sodium hydroxide, I would need to have 40 grams of sodium hydroxide. So I have approximately 0.0375 moles of sodium hydroxide. Now I need to turn that into a concentration. Molarity is moles per volume, moles per liter. So I have 500 milliliters, which is half a milliliter. So to turn that into concentration, right, I have 0.5 liters. So I divide by 0.5 to get a concentration of 0.075 molar sodium hydroxide. So that's step one. We found our concentration of sodium hydroxide. Sodium hydroxide is a strong electrolyte, so when I put sodium hydroxide in solution, it's going to ionize completely to give me sodium cations and hydroxide anions. So the concentration of sodium hydroxide will equal the concentration of hydroxide in solution. So I know the concentration of hydroxide, 0.075 molar. And I'm asked to calculate the concentration of hydronium. So now, our second step of that calculation, we know from the autoionization of water, the concentration of hydronium times the concentration of hydroxide equals 1 times 10 to the minus 14. This is the autoionization of water. We know the concentration of hydroxide. That will allow us to find the concentration of hydronium. So hydronium is our X times our concentration of hydroxide, 0.075, equals 1 times 10 to the minus 14. Divide both sides by 0.075 molar. And we'll see that we're left with the concentration of hydronium of approximately 1.33 times 10 to the minus 13. So we use the mass of sodium hydroxide to find moles, and then finally concentration, which is molarity, moles per liter. Once we knew the molarity, because this is a strong base, sodium hydroxide, it ionizes completely, so the concentration of sodium hydroxide equals the concentration of hydroxide in solution. That allowed us to then, using the autoionization of water, to find what is the concentration of hydronium in solution.